Happy Friday. So today we're going to talk about optical sorters. As you know, we sell the Chromasort brand, but we're going to go into depth a little bit about what they're used for, what you can use them for. Historically, optical sorters have been used especially in the food industry, and then over the years, more and more industries have taken that and applied it to their industry. So in the food industry, when we first noticed these, they were being used in the rice industry, and rice is really small and very similar to the copper chops. So that's really what kind of got my attention, and I thought it was really a cool application. And they're able to sort by color, they're able to sort by size, by shape. So if you're doing like grapes, for example, the grapes are going across it. If you have grapes that are mushy or not the right shape, or you can eject those out of it. So same thing for the ore industry and mining industry. They'll take ore. So if you're doing like quartz to get the silver or gold, and you have other materials that are in there that's not quartz, you have other rocks, you can sort those rocks out of there. So some optical sorters use paddle ejector switches. The ones we use are using nozzles. So we're gonna go dive into it and explain a little bit of how that works. A lot of time and effort goes into making these videos, and the real reason for these videos is to get you as much information as possible. If for some reason there's information or questions that you have, make sure to put those in the comments below. I'll do my best to answer. And if you want a quote on any of the equipment that we discuss or talk about, there's a link to a form for that down below as well. There's also two kinds. There's a chute kind, which is used a lot in the food industry and especially in the grain industry, where material falls down a chute, and there's a camera that's on the bottom and one on top. And what happens as the material's coming through here, the cameras detect it, and then you have the ejector port down below, and that ejector port is going to go ahead and shoot it. Sometimes it shoots down, sometimes it shoots up, depending on the style. But what ends up happening with this is, if you have, for example, in our industry, if you have a flake of aluminum, that flake of aluminum that's just dropping down that chute is going to travel at a different speed than a copper nugget, right? So that's why we like to use the style that is on a conveyor belt. So there's a conveyor belt and there's a feeder that feeds the material onto a pan feeder. The pan feeder puts it onto the belt, and then as the belt is bringing the material through and it drops it, everything is traveling at the same speed. Then we have a camera bottom, camera on top, and as the material comes down past the bar is a little bit below this, after it's seen it, it's almost instant. It sees it, it shoots it right away. So there's not like a long distance travel as it's going through here. So then this ejects it, and the bad stuff, or the stuff you want to eject, goes in the other side. The benefit of the chute is it's a little bit cheaper. You have a little feeder, it goes right in and it falls into it. But the downside of the chute is that what you're going to have is that some materials flow faster and fall down faster. So that's the downside of the chute. The benefit is it's cheaper, it's a little more compact, there's less moving parts. But the downside of it really is, once the material falls through that camera, in front of the camera as it's going through here, it's going to be falling at different speeds because it's just using gravity. So if you have something that's, if you have a big piece of copper, it's heavy, it's going to go flying down that chute, and it could overshoot. So now you have the nozzle, and the nozzle's trying to do a puff of air. And the way that these are set up is in milliseconds. So after it sees it, how many milliseconds later does this nozzle shoot? So as the material's coming through, we'll make this a little bit better. So these would be your cameras on both sides. So as the material is coming through, how many milliseconds later does this nozzle shoot the material? So if you have it for, we'll say 360 milliseconds, and that's how long it takes for your material to reach from this point to this point. If you have a piece of aluminum and it takes longer, well, now you've said, okay, 360 milliseconds later, I want this thing to shoot. Now your material reached this point here, and now your aluminum is here when it shoots. So now this is missing your aluminum because it's coming at a different speed. So you would have to have this, and it's near impossible to do that. So this here is going to be kind of a fixed number. I'm sure as technology gets better and AI and everything, eventually we'll be able to say, okay, like I detected this material going at this speed, therefore it's going to be here. Things get better every year, so I wouldn't be surprised if that happens. But currently, everything is set. You set, okay, for whatever recipe you have, this is at a certain speed. And now if you have material falling down at different speeds because they're different weights, you can have it either overshooting the nozzle or undershooting the nozzle. And then the nozzle's not able to be as accurate because it's trying to shoot at that same time. Whereas the belt one, the material falls, it sees the material's moving, it's being launched by the belt. So it's moved at a certain speed and it goes across the camera and right away the nozzles are there. So it's losing, it's being projected at the same momentum, and sure, it's going to lose momentum. The further it goes, it's going to be more and more inaccurate, but right where it is, it's more accurate than this because this is further down. One of the things to keep in mind when you're sorting with optical sorters is you're always trying to shoot out the item that you have the least of. So in our case, we do a lot of copper. We deal with a lot of copper. So you got copper chops, you're separating everything through, and then you have aluminum or brass. You want to shoot the item that you have the least of. So the aluminum and the brass, you want to shoot that out. So now you end up with a fraction that has clean copper. That's what drops down. And then you have your aluminum and your brass that kept going. Now, there's also a two-tier system where that's available where we can have another set of cameras and ejectors that shoot that and separate. And then you have 3 clean fractions. But your cleanest fraction is always going to be your first fraction. So if you're cleaning copper, you're going to go ahead and shoot out everything else. Then you can take whatever you shot out. You're going to end up having a little bit of cross-contamination. So for example, if we deal with copper and you got a bunch of specks of copper and then we have a piece of aluminum here, when it shoots on this, you're probably going to have a few pieces around the outside that get carried over with it. And I'm exaggerating it a bit. There's going to be less carryover than what you're shooting. So if you're shooting aluminum, yeah, you're going to shoot the aluminum. There's going to be some pieces of copper that gets shot with it. Now, that's normal. And then that's how you end up with the cleaner fraction that falls down. But the carryover that goes over, the little bit of copper and aluminum that goes through, then when you sort that product again, you'll have your rejects, you'll put it back through the system. That material that you're putting back through the system, you're going to be putting it on the reverse program. So you're going to be, in that case, you're going to be keeping your aluminum and shooting the copper. And then you're going to have clean aluminum, and then you'll have copper that might have a little bit of aluminum that it carried with it. So you're always going to have one fraction that's not 100%, and that's normal. The goal is to have quality control. So when you're buying these systems, you're not trying to get 200% clean products. You're trying to take your main product. So if your product is selling copper chops and you want to sell clean copper chops, you're trying to run a program to where you're doing quality control in your copper chops and selling 100% clean copper, and then whatever it rejected, you're going to run that through your system a second time. So in the recycling industry, we see these for separating, glass, metals, paper, based on color or even shape sizes. So for example, with Zorba, if you run Zorba through this process, you're going to end up running your Zorba on an on an eddy current. So that eddy current is going to make a Zorba package. You're going to have some aluminum, some brass, some copper, and then you can take those larger fractions, put them on, and you can sort them by size and shape as well. How does the double stack work? So the double stack works very similar to the other one in that the material is coming over and falling over the head of the pulley, and then as it's getting ejected, the ejection port, you still have camera top, camera bottom. As the material is getting ejected past, you have another camera and another ejection port that is cleaning this fraction that's coming through. So you have this being separated a second time. So and the way these cameras work is on the 1200 series, it's a bank of 4 cameras on top, 4 cameras on the bottom. What's important about the cameras some companies make them with just 1 camera on top. What's interesting is like when you're doing aluminum copper radiators, for example, you'll get a chunk of aluminum, the other side is copper, right? So they're sandwiched together. You'll have one side that looks perfect, but then you flip it to the other side and it's not perfect. So by having a camera top and bottom, you're telling the system, hey, now you can train it, you can have it, you can turn it on and off, you can do one way or the other. You can add different colors into it. You can turn a blue light, you can turn a red light, you can turn intensity. So there's blue light, green light, red light, and then you can turn those intensities up and down to make whatever color backlit you want. So as the material is coming through, the camera is looking at it and it's shining a white light towards it, and it's backlit with the opposite. So in the same array, I'm going to draw this here. So in the array, you have these really bright white lights, and then you have the cameras. There's 4 cameras, and then you have the color. So this here is your color. And so this here, you have an identical one to this at the top, and it's looking at the material, and the material, it's looking at this. So these cameras are looking at this back color and using the front light to shine the material. And this one is doing the opposite to the other side. So as the material is coming through, the other camera is looking at the material as it's falling across this. So it's backlit. It can be backlit blue, purple, green, red. So you can use these different colors based on what the material is. So like copper, you really don't want to use purple because the copper kind of has a purple tinge to it. So blue works better for that. But it's all customizable. So you can set the color of your backlit to be based on what you're sorting, to have a better lighting and for the camera to better see it. So the cameras are looking top and bottom. Now, what's nice about that is that you're always getting a view, and you can tell, okay, this is nice on this side, but this side it's not nice. I want to reject that. So you get a better sorting by having top and bottom camera. All right, so what are the benefits of an optical sorter? An increase in efficiency and throughput due to for manual sorting. So I remember seeing some people were on this output of their copper sorting system. They had people, manually looking at everything. That's pretty rare that you'd have to do that. Most of the time, your air tables take care of that. But if you have the odd, white metal die cast, something that's really heavy, almost as heavy as copper, like zinc. Zinc is is very dense. Then that can come in your copper, and you want to be able to have a way to sort that. So a lot of times for systems like this, what you're going to do is put it as a separate standalone quality control. So you have a hopper, you can run it lights out, fill up your hopper with copper, put your 2 bins in the front side, and then the copper goes through it. You get clean copper, you get a little bit of whatever you ejected, aluminum, brass, shot out of the copper. So it improves your product quality. You're going to minimize waste and maximize material recovery. Other applications for scrap are aluminum copper radiators. So if you wanted to run, shred aluminum copper radiators to like 1 inch or 1/2 inch or so, and then you wanted to do a gross sort, so like sort aluminum from copper, you can do that in a zigzag too, or a sifter, but you could do it on this, do a pre-sort, and then you could granulate both materials, and they're not all commingled, so you have mostly copper, mostly aluminum. That does for a good pre-sort. So that's one application. Copper, brass, aluminum. Aluminum chops that have a little bit of copper in them. So if you have, number 1100 series aluminum chops, and you might have a speck of copper here or there, and you want to pull that out, you can do that. Same thing with EPDM rubber. So you have the rubber from the doors, right, in the cars when you're recycling that. That has aluminum, so those get shredded and chopped. We have a couple videos about that. When that gets shredded, you're going to want to pull off all the aluminum. So on the air table, you can sort that aluminum, but then sometimes you'll have a piece of rubber that's stuck on the aluminum, so you can, a little piece of black rubber, so you could put that on there and shoot that black rubber out. You could also take that rubber, because that rubber has a lot of value, put that on the optical sorter, and then shoot out any aluminum contaminants that could have fallen into that rubber. So e-scrap, the boards from e-scrap, you can sort that by shape, by size. You can sort out the heat sinks. So there's a bunch of little different things that you could do. It most of the time, it's not going to be used for your mechanical sorting. Your mechanical sorting is going to be, your air tables, your grinders, your screeners, your sifters. It's once you get that final product, when you have your good final product and you're getting ready to sell that, it's for quality control. How good is this copper chop? How good is this aluminum chop? How good is my package? If it's not good enough, you can run that through the system. And even if it is, right, so some guys are running these regardless. They just want to have that final level of security or safety to know that their material is good. So it's going through there and just checking it one last time. So really it's good for that. For the quality control, we build these as quality control stations for your final stuff. Like most of our chops that we sell are really clean. They're very clean. But if I want to avoid rejections, I can take all of my chops all the time and put them through there. I can run it lights out, and then it can just clean it out. So maintenance costs on these are relatively low. One of the benefits of the unit that we sell is it sips air. It doesn't use a lot of air. We talked about this in one of our other videos. A lot of optical sorters out there have big nozzles and they're shooting like just tons of air. You can really hear it popping. This here, when you hear it running, it's a small pop, 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 pop. It doesn't use much air, and the way that they do that is the bar, the material, it's getting everything to fall in a certain arc, really close to the bar, and then the splitter bar is a little bit lower, and then it doesn't have far to travel. Now this is all adjustable, so in larger materials, we can take this bar and we can move it further back. So if we're doing larger pieces of material, we can move it back, and then we can increase how long the nozzle is on for and what the pressure is, so we can mess around with that. But for most of what you're doing, this machine is set up to use very, very little air. I got a customer that's is actually right now, and I don't suggest using this typically, but I mean, he's got a Home Depot air compressor and the thing's keeping up pretty nice considering what we're putting through it. So it doesn't use a lot of air, and it's not much electricity, right? It's a little vibratory feeder. In total, I think it's under 10 amps total of all the components in it. So very little electricity. Compressed air is a cost, obviously, but it doesn't use as much compressed air as most of the systems that I've seen out there. Even one of the early ones that we were testing, it used a lot of air. We needed a lot of air to keep it going, and we'd run out of air pretty quickly. So with this, it's much better as far as cost-wise. What's also neat about this is that everything's as recipes. So once you build a program around, for example, separating aluminum from copper, you're going to have it be in a recipe in the screen, and then if you want to copy it, you can just copy that recipe, have it flip-flop, and then you say, okay, you rename it. So you can say, okay, I have a recipe that's ejecting aluminum out of copper. Well, I like all the settings. This is the sample of copper that I have. And this is the sample of aluminum that I have saved in the system. I just want these flip-flop, and you can do that. So the settings, but then if you want the adjustment of how soon before it shoots to be slightly changed, you can change that in the other program. So you don't have to edit the main program. You can just make a copy of that program and then just edit that second program. So there's a lot of functionality for training the system. You just put a couple pieces of the material that you want to keep on it. It takes a picture of the material. AI just quickly circles up all the material, so it recognizes every piece as a separate, kind of like a separate pixel. You say, okay, I want this, I like this, and then what happens too is that if you, for example, if I put a handful of copper on there, and by accident there was a piece of aluminum in it, when I take that picture, I can grab that piece of aluminum and say, actually, I want this to be on the bad side. And then you flip it over to the bad side. And you can do the same thing for the bad side. If I have a handful of aluminum, put that on there. So, okay, now I'm taking a picture of the bad side, and I take that picture, and then there's some components on there, some pieces on there that I say, okay, I want that to be on the good side. I can just select those items and hit the little arrow, and it puts it on the good side. So you can take items and move them back and forth on both sides depending on the material. So that's another really cool feature for training it. So training the system is actually pretty easy. It's not a very big, long process. You can take one of the programs that's already in there, one of the base programs, and then you can put your own pictures, your own analysis, and then run the program. The 1200 series is about 1 ton per hour, and then there's a 600 series, and that's about a 1/2 ton per hour. They're just there's a scaled down version of it. If you go to the double stack, you're not getting any more throughput, unless if you do have it programmed, so you can run it fast. If you have the double one and you're cleaning copper, then you can run it faster. You can actually run it a little bit dirtier, because then whatever it's shooting, so the reason why you can only do 1 ton is because you're gonna miss some material. So if you have, for example, copper, you're doing a ton an hour of copper, and that ton an hour has a little bit of aluminum in it. As you're shooting that aluminum out, if you start overwhelming the machine, right, and then it's shooting like crazy, you're gonna have more material that goes over than you would want, and you got a lot more copper that's getting rejected. Now, if you have that with the second level, you can overwhelm it a little bit more, because you have that second level of protection. So you could run it probably a little bit more, maybe 1.5 tons or so. But typically 1 ton an hour for these systems for the 1200, and about half that for the 600. But what's the benefit of this is that you can run lights out. So even after hours, you can continue to run and get the throughput and production that you would otherwise not get during the day. If you're interested in getting a quote on this, fill out the request quote form below. And if you have any questions, put them in the comments or reach out to us directly, info@cablemagementusa.com. Like, comment, subscribe. We'll catch you in the next one. Happy Friday.